Good afternoon, students. In this session, I am going to explain about the adiabatic process. Children, already we studied about the types of process, right? Types of thermodynamical process. In case of types of thermodynamical process, there are many types and the previous types are we already studied. You know that in case of thermodynamics, the thermodynamical variables such as pressure, volume, temperature, heat. You got it, no? So what is that? Already you know that. Pressure. Next, volume. Volume. As well as temperature. Temperature. Then heat. And later you know temperature is related to internal energy. Internal energy. Right? All these are different thermodynamical variables. They will change when you supply the heat. All are interrelated, right? Now, our duty to understand what about the types of thermodynamical process. Types of thermodynamical process. Right? Process. And depends on these parameters. Already we learned if in any process pressure of the system remains constant. Pressure of the system remains constant. Then such process is said to be isobaric process. We studied already. Only my intention to now recall all the types of process what we studied already. Before stepping into adiabatic process. Isobaric process. What is the meaning of isobaric process? In case of isobaric process, if you can see in isobaric process, the pressure of the system remains constant, right? So what is that? If you see any process in which the pressure changes from P1 to P2 in general. P1 is initial pressure, P2 is final pressure. But in case of isobaric process, P1 is equal to P2. If you find out the delta P is equal to P1 difference P2, it is nothing but 0. Change in pressure remains 0 in case of isobaric process. Okay, this is one type. Now let us come to the another type of the process where process carried at constant volume. Volume remains constant. Such process is said to be, already you know children, only our duty to recall the points, isochoric process. Isochoric process. Okay, this is one thing. In case of isochoric process, same. If you study, what about isochoric process? In case of isochoric process, volume changes from V1 to V2. But isochoric definition itself, V1 is equal to V2. That indicates that delta V is equal to V1 difference V2 is equal to 0. Now, we studied already about the isothermal process. What is isothermal process? Let us try to understand. When temperature of the system remains constant. Temperature of the system remains constant. Okay, what does it indicate? Such process is said to be isothermal process. Okay, isothermal process. isothermal process. This is one case. In this case also same. In case of isothermal process, T1 changes to T2 during the process in general, right? Here isothermal T1 is equal to T2. So delta T, that is T1 difference T2, is 0. And here one more thing you should remember, children. Internal energy of the system is directly related to the temperature. So what you can say, if temperature remains constant, internal energy remains constant. Because internal energy is a main factor of the temperature. So what we are calling that, in this case, U1 changes to U2 in a types of process, then immediately you can say U1 is equal to U2 and difference of delta U is equal to U1 difference U2 is 0. You got it, no? That is isothermal process. Okay, now these three processes we already learnt in detail for your competitive examination point of view, right? Either NEET or JEE or any other type of competitive examinations. Now the fourth one, children, we should know, when heat remains constant, then such process are said to be adiabatic process. Okay, when heat of the system remains constant, such process is said to be adiabatic process. So children, in this video, let us try to understand what are all the consequences as well as the topics involved in the adiabatic process for our competitive examination point of view. Okay, let us try to solve some relevant problems at the end of this session. Okay, so see here, now let me step into in depth of adiabatic process. Okay, adiabatic process. Okay, what is actually main criteria or definition of adiabatic process? I told that already. If any process carried at constant heat, you got it, no? You know that in case of thermodynamics, there exists a system, right? System as well as surrounding, right? Surrounding. Okay, when always there is exchange of thermodynamical parameters such as pressure, volume, temperature, heat, internal energy, all between the system and surrounding takes place. System is nothing but a specified matter under which consideration for our study, right? Always system exchange something with the surrounding, or surrounding exchange something with the system. That type of exchanging is said to be thermodynamical process. Okay, now let us try to understand what about that thermodynamical process. Okay, adiabatic process. So in case of adiabatic process, what happens actually? P1 changes to P2, V1 changes to V2, T1 changes to T2, and Q1 changes to Q2. But in case of adiabatic process, Q1 is equal to Q2. There is no exchange of heat between the system and surroundings takes place in case of an adiabatic process. Okay, in case of an adiabatic process, there is no exchange of heat between the system and surrounding takes place, and it will give lot of difference in case of thermodynamics. Okay, you know that without heat anything you cannot study easily. For example, if you take a ideal source of the light and heat is nothing but natural source, sun. You got it, no? So there is also thermodynamical process happens, you know that, in second around 500 ton hydrogen burns, it gives light and energy, isn't it? So what is that? It is what is that? The main source of sun is nothing but a hydrogen. It converted into helium. 4 hydrogen atom converted into helium to produce heat. You got it, no? So what is that? In that way, same way, thermodynamic process exists everywhere in our day-to-day life, in our field of life. Correct? Okay, let us try to understand what happens if heat remains constant. You got it, no? In practice, adiabatic process can be realized only the system is thermally insulated from the surroundings. You know that heat should not flow if you take anything inside a perfect container, right? It is nothing but a container. So what is that? Here it is nothing but our system exists, right? Here system exists which surrounds the system, surrounding, correct? Surrounding. But here what happens that actually there is no heat flows between the surrounding and system takes place. Q. It never flows. You got it, no? There is no exchange heat between the system and surrounding. What does it mean? Whatever this dividing wall is there, right? It is nothing but a protecting wall. This is thermally insulated wall. Thermally insulated. Thermally insulated wall. What is the meaning of thermally insulated wall? This wall will not allow heat to flow from system to surroundings. It acts as a protecting wall, just like thermos flask. You got it, no? It may be vacuum in between that. It may be there is no medium in between that system and surrounding, but it is adiabatic process. Clear? Now let us try to understand the propagation of sound in air. Children, you might know, if you wanted to get the example in real life, day-to-day life. First one, the propagation of sound in air. Propagation of sound in air. This actually propagation of sound in air is the best example for an adiabatic process. Actually, Newton thought propagation of sound in air is due to the isothermal process. It is a slow process. During the transfer of sound from one position to another position through the air, there is a alternate compressions and rarefactions takes place. Okay, but that process happens at constant temperature. It is generalized by Newton. Newton gave one formula: speed of sound in air is given by square root of b by rho or p by rho. Okay, but Laplace corrected because there is a disagreement with the theoretical value what they calculated by Newton's formula and experimental value. So there is a little bit correction made by Laplace. Laplace told that it is not an adiabatic process. It is not an isothermal process. It is an adiabatic process. Okay. Then speed of sound, he told that v is equal to square root of gamma p by rho, where gamma is specific heat, ratio of specific heat of gases, Cp by Cv. Gamma is equal to Cp by Cv. Okay. The rho is density in which that sound flows. Density of the medium. P is the pressure. You got it, no? Second example, if you take, what is the second example for adiabatic process? The bursting of a tire. Bursting of a tire. It is a sudden process of a tire. You got it, no? Always adiabatic process is a sudden process. You should know, children. Okay, it is a sudden process. Is it clear? Okay, now let us try to go different steps involved, or what are the methodology, what are the concept we should remember for our competitive examinations in case of an adiabatic process. Already, as we learned, in case of an isothermal process, there are different situations, right? Okay, now what we will see. Now first one, first character. In adiabatic process, delta Q is equal to 0. Children, already we studied what about first law of thermodynamics. In case of first law of thermodynamics, correct? First law of thermodynamics, delta Q is equal to delta U plus delta W. Delta U plus delta W. Okay, one thing. Next, now if you study what about heat capacity or molar heat capacity? Molar heat capacity. molar heat capacity in case of adiabatic process is? Because what is molar heat capacity? Already you know, if you say C is the symbol for molar heat capacity, C adiabatic is given by rate heat flowing in 1 mole of or n moles of gas when there is a change in temperature delta T. Okay, so C adiabatic is delta Q by N into delta T, where N is number of moles, delta Q change in heat, delta T is change in temperature. But in case of adiabatic process, since delta Q is 0, anything by 0 by anything is 0, you know that, so it is no doubt it is 0. But if you see what about the isothermal process, that is C isothermal heat capacity, molar heat capacity in case of isothermal process, that is delta Q by N delta T is equal to infinity, since delta T is 0 in case of isothermal process. Correct? Delta T is 0 in case of isothermal process. I think you understood. Clear? Okay, let me proceed. The next step. So C adiabatic, C isothermal, we come to know that. Okay. Now let us try to move the next point of the adiabatic process. Okay. What is the next point? Let me explain. See here, already we studied one point. The second point is given by, if you see the second point. Okay. What is the meaning? Second point. According to the first law of thermodynamics, already I told that delta Q is equal to delta U plus delta W. Delta W. Okay. Then what happens that in this case, anyhow delta Q is 0 for adiabatic process, correct? So you can you write it is 0 is equal to delta U plus delta W? Isn't it? So what you can write? Now you can change. What about the work done? Work done is nothing but negative of delta U. Work done is nothing but the negative of delta U. What does it indicate? The work done by the gas equal to the decrease in internal energy. So what does it mean? The work done by the gas. Work done by the gas. By the gas equal to decrease in internal energy. Decrease in its internal energy. Internal energy. Work done by the gas is equal to the decrease in the internal energy. Correct? So what you are getting? Now there are two types, children. What you can think that, what is work done actually? In case of thermodynamics, work done is given by volume change, right? Work done or delta W is equal to P into delta V. P into delta V, where P is the pressure, dV. dV is nothing but V2 minus V1, or difference of that. Final volume minus initial volume. If you see dV is negative, then delta W is equal to negative. dV negative means volume decrease. Volume decrease means we will call compression. You studied mechanical properties of solids, right? Volume decrease on applying the pressure. So what is that? Here compression takes place. So there are two types of adiabatic process. Imagine instead of that, if you say V2 minus V1 is equal to dV is positive. And this is nothing but what we are calling, it is compression, right? It is compression. And in this case volume increase, that is expansion. Expansion. So if dV positive, expansion takes place, dV negative, compression takes place. Whatever, either expansion or compression, work done is given by P into dV. You got it, no? So what is that? Work done either by compression or expansion takes place. And if the process is adiabatic, there are two types of work done. One is adiabatic expansion, another one adiabatic compression. Adiabatic expansion to adiabatic compression. Adiabatic compression. Adiabatic expansion and adiabatic compression. Okay, there are two parameters. Then if you say in this case, so what you are taking in case of adiabatic expansion, delta W is positive. Delta W is positive. If delta W is positive, delta U is negative, because you know that positive work done in case of adiabatic process is due to decrease in its internal energy. In case of compression, delta W is negative. That indicates that delta U is positive. So you should remember, you got it, no? So what you are calling in this case, if delta U is negative, delta U negative indicates that the temperature decreases. Delta U negative implies temperature decreases. Temperature decreases. If delta U positive, that indicates that temperature increases. Temperature increases. So you should remember here, in case of adiabatic expansion, work done positive, so that internal energy should decrease. If internal energy decrease, temperature should decrease, because direct relation. In case of adiabatic compression, delta W positive, then the delta W negative, so that there is increase in internal energy, so temperature of the system increases. You got it, no? These are the types what we are calling. Okay, so what is that? These are the things what we should know. Now let me move towards various relations in case of adiabatic process. Various relations in case of adiabatic process. Various relations in case of adiabatic process. Okay, what is that actually various relation? There are many relations towards your competitive examinations. You should remember, children. First relation between P and V. Relation between P and V. Second, relation between V and T. Relation between V and T. Next one, relation between P and T. All relations are important towards your competitive examination, but your board exam, this much not required. Okay, you can just give relaxation for some topics, P and T. Next one, fourth one, relation between P and rho. Relation between P and rho. Okay, you should remember relation between P and rho. Then that things, what is the relation between P and rho over? Same way, next you should remember fifth one. It is 3 over in this it is okay. Now later we will go for the slope of the adiabatic curve. It will leads towards the compressibility, all those things later we will discuss. Now let us try to understand relation between P and V, relation between V and T, relation between P and T, relation between P and rho. All relations are important in case of an adiabatic process. Okay, what are the relations actually? Let me try to explain you. Okay, now first relation between P and V. Relation between P and V. Actually, for competitive examinations, derivation nobody will ask. You know that, isn't it? They will give the applications. But if you know the derivation, how all the formula came, you can easily grasp the answer or steps while solving the questions of your competitive examination. Already you know that option based questions they will ask, as well as integer based questions they will ask in the JEE exams. NEET anyhow they will ask only option based questions, right? 45 questions they will ask, and when compared to the level of difficulty in case of JEE main, they will link the topics, one or two or three topics, but in case of NEET they will ask direct questions. You know that level of difficulty is less for NEET and more for JEE. Okay, that you should remember. Now let us try to understand the relation between pressure and volume, children, in detail by deriving the equation. Okay, so what I will take, children, consider an adiabatic process on an ideal gas. For that case, consider an adiabatic process for an ideal gas. Then what happens that, children, I will tell you the pressure P which changes to P plus dP, volume V which changes to V plus dV, and temperature T changes to T plus dt. T plus dt. Okay, and it is nothing but an adiabatic process. Adiabatic process. Adiabatic process. Okay, so pressure changes from P to P plus dP, volume changes from V to V plus dV, temperature changes from T to T plus dt. Okay, this is an adiabatic process. Now let us move towards the first law of thermodynamics. What you studied that from the first law of thermodynamics, because our duty to obtain a relation between pressure and volume for an adiabatic process. First law of thermodynamics. First law of thermodynamics. Already you know, children, no need to say again and again. dq is equal to dw plus du. Okay, du. This is one equation. But in case of adiabatic process, since dq is equal to 0, you can write immediately 0 is equal to du plus dw. Children, already I told